Okay, so we are officially in Chapter 2, and Chapter 2 is all about fraction and decimal operations. So today we're going to be reviewing how to add and subtract fractions with common denominators. So let's go ahead and look at a model for this example. The first one says 1/3 plus 1/3 equals 2/3. You can see in this model they have a whole and it's broken into thirds. 1/3 is filled in here, plus another 1/3, and then they combine those two to equal 2/3. Now they do the same thing with subtraction. You see they have a common denominator of 4, so each of our wholes is broken into 4 pieces. The numerator tells us that we have 3 out of 4 pieces minus 2 out of 4 pieces, and if I were to take away 2 of these pieces, I'd be left with my 1/4. Okay, so go ahead and give it a try for this first one. I want you to draw a model and then solve. So 2/3 plus 1/3. Go ahead and pause before I reveal the answer. So right here, I broke my figures into thirds because my denominator is 3. And the first one says I have 2/3 plus 1/3. And together I'm going to have 1, 2, 3 pieces filled in. So 3/3, which we know equals 1 whole. Now if you drew a model for the rest of them, for number 2, you would have gotten 2/4, which you could simplify by dividing the top and the bottom by 2 to get 1/2. And we always want to make sure we're simplifying our fractions when possible. 3/4 minus 1/4. 3 minus 1 would be 2 pieces out of 4, which again I can simplify to give me 1/2. And then my last one says 2/3 minus 1/3. So this one is broken into thirds, and 2 minus 1 equals 1, so 1/3. Okay, so to put it in words, when the denominator is the same, to add or subtract fractions, you write the sum or difference of the numerator over the denominator. Now you will see we will start giving examples with both numbers and an algebra. So on the left-hand side, it gives you an example. The denominator is the same, which is what it says right here. To add or subtract fractions, write the sum or difference. So sum or difference, 1 plus 2, the sum would be 3 over our original denominator, 3/5. And then in algebra, it says if you have a over c plus b over c, you can see our denominators are both c, so our denominator will stay the same, and then you write the sum of a plus b, so a plus b over c. And again, remember we talked about why our denominator cannot equal 0, and that is because every fraction is a division problem, and you can't divide something into 0. So let's look at an example one more time. 4/13 plus 6/13 equals 4 plus 6/13. Now I'm going to simplify, and simplify means to combine your terms as much as possible. So 4 plus 6 equals 10, 10/13, and I ask, can I simplify that fraction at all? And I cannot. And here's an example for subtraction. 7/8 minus 3/8. I'm going to write the difference as my numerator, so 7 minus 3/8. And 7 minus 3 equals 4, so 4/8. Now can I simplify this whole fraction at all? I can divide both my numerator and denominator by 4, because 4 is a factor of both 4 and 8, which would give me 1/2. Okay, go ahead and try these two on your own. Go ahead and pause the video, and when you're done, come back and play. So you have 3/5 plus 4/5. So I'm going to rewrite the problem, which is what you guys should always do when you're doing a problem for your homework. And then I write the sum as my numerator, so 3 plus 4/5. And that will give me 7/5. Now notice that this is an improper fraction, so you could have turned 7/5 into a mixed number, and you would have gotten 1 2/5. Moving on to our subtraction problem. We have 5 over 16 minus 3 over 16. I'm going to write the difference over my denominator, so 5 minus 3. And you remember the difference is just the answer to a subtraction problem. And that would equal 2 over 16. Now, can I simplify 2/16 at all? Well, I know that 2 is both a factor of 2 and 16, so I can divide by 2 over 2, which would give me, sorry about that, 1/8. And the last thing we're going to talk about is we're slowly going to start getting used to algebra and introducing you to these concepts. So, a variable is a letter used to represent one or more numbers. An algebraic expression consists of numbers, variable, and operation. So look at this one right here. Our variable would be n. N is representing a number or more than one number. Then our operation is addition. And then the number we have is 6. So it says n plus 6. That would be an algebraic expression. Now if it says to evaluate, you are going to solve. So to evaluate an algebraic expression means to substitute values for the variable and then solve. So on the next page we're going to go over how to evaluate properly, but this word is used a lot throughout 6th grade, so it's important that you remember what it means. It means to substitute a number in for the variable, and then you're going to solve it regularly. Okay, so this one says evaluate the variable expressions. Evaluate the expression x minus 5/12. And then there's two different examples. So it says when x equals 11 over 12 and when x equals 7 over 12. So what I'm going to do is I'm going to take this right here, and it's telling me that x equals 11 over 12. I'm going to put it right where this x is. So 11 over 12, I'm substituting it in, minus 5 over 12. And then 11 minus 5, that would be the difference of 11 and 5, would be 6. And then our denominator stays the same. And 6/12, you can divide both the top and bottom by 6 to get 1/2. And then it says, I need to evaluate this expression when x equals 7/12. So I'm going to plug 7/12 into my x. And when I do 7 minus 5, I get 2 over 12. And then I can simplify by dividing the top and the bottom by 2, which would give me 1/6. So that is how you evaluate an expression. And that is it for lesson 2.1.